Okay, welcome back. Here we get to page 2, part 2 of this review for this sample for this interest test that we're having coming up. Again, we'll go over some of these in class, but we'll at least touch on how to work out each of these and tell you the answers so that you can work on your own and check your work. So here at number 5, we have Juanita wants to save money so her grandson can attend college. She decides to give him $25,000 on his 18th birthday. If her grandson was just born, how much will she need to put in an account that pays 5% compounded weekly to reach her goal? So again, we see compound, and we know that we can see that compounded word coming up, whether we're talking about interest or, whether we're talking about compound interest or with an annuity. The important thing we have to decide here is how often is it done. And she's only putting it in once. Okay, so we know we're dealing with one of our compound interest formulas, either the amount one or the present value one. Now in this problem we want to know how much does she have to put in. We, in other words, want to know the present value. So we will be using this formula. And then we can work that out. So she wants $25,000. And now the interest rate is 5% and it's compounded weekly, and she's starting now for his 18th birthday. So 1 plus 0.05 weekly, so over 52 to the 52 times 18 power. Okay, and then we work that out. And we find out she needs to start today with just over $10,000. Again, money we round to the nearest cent. It's 0.637, so rounding off we'd say 0.64. Okay. Now as we continue on here, number 6 says at age 12, Erica has completely planned out her whole life. At age 30, she wants to meet the man of her dreams. She wants to get married. The important thing is she wants a $34,000 dress. She convinces her father now to start saving right now. So how much will he need to invest in an account that pays 6.25% compounded monthly? Okay, this is actually the same problem. It's a one-time thing. It doesn't say he invests each month. It says it pays interest each month. So very important. That's a one-time thing. So we're still using this same exact formula again. So using that formula, you will work out that he needs to have $9,772.81 today that he can put into the bank to get her dress in 20 years. The final one on this page talks about a distant ancestor who put $2 into an account. Again, it's a once-time thing. And left it there and set from 1704 to today. Well, if we're in 2017, going back to 1704, that's 313 years that it's been in that account. We want to know how much will be in the account now. So we're still back to our compound interest. And then we use our compound interest formula. Now when we do that, we see that given 313 years, at $2 has actually grown to over $283 million. Quite remarkable. And this really illustrates again the time factor of compound interest. The longer it is, the more it will grow.